Morgen. That's all the German I know, I'm afraid, so apologies for that. I was here last year and I had a great time, so hence me being back. So thanks very much for the invite to come back. I'm really excited about the rest of the 2 days, actually. So hopefully I can start things off with something interesting. So I'm going to be talking about beating your competitors with the subtitle, It's Not All About Me. And what do I mean by that? Well, I'm going to pose some questions about why we write software. I'm going to try and answer a few of them, and I'm going to be talking about, I think, the thing that I find most interesting with respect to both writing software and also specifically around microservices, which we'll come on to in a minute. First of all, I'm going to get this out of the way. So if anyone's got the Conway's law on bingo card, you can tick that one off straight away, okay? So, because actually this is in large part what this talk is about. It's about organizational design, it's about organizational structure, and the impact that has on software architecture. So my colleague Ian Cartwright's got a lovely phrase. He says that business and technology should be isomorphic. Right. So if you look at the technology, if you look at your software estate, you should be able to see your business reflected in your software estate. Similarly, if you're a business person, if you're a technologist and you look at your business, they should look the same. So that's what I'm going to talk about initially. I should ask, because I know he's been popping up at conferences, is Melvin Conway actually in the room? He was at no hands up. Good. You have to check, because this is, maybe I don't know if this is a bit mean, because this is what I think of Melvin Conway when I think of Melvin Conway, that guy in the Muppets, right? Who's sitting on the balcony and he's commentating on what we're all doing. Right, so Melvin Conway, back in 1968, he drew attention, based on work in information theory, to the fact that the software we build mirrors the communication structures of the teams building it. Quite simply, if you have fine-grained communication, you have fine-grained software. If you have coarse-grained communication, you have coarse-grained software, or dependencies between software components. And as I say, this was back in 1968 that Melvin Conway started talking about this. He wrote the first paper back then. And I think he's this guy sitting on the balcony, because I don't think we've learnt the lessons of Conway's law yet. I don't think we apply this as we should do when we're building software. And we see this, I see this all the time. I'm a consultant, I spend a lot of time in lots of different organizations. I see lots of different organizational structures, lots of different software platforms. And I see Melvin Conway laughing at people all the time, essentially. I'll give you an example of that, somewhere I was at recently. They were building out a really nice, well thought out microservices, TM, microservice ready, TM, architecture. But they'd organize their teams as, I guess, sort of feature teams. And that sounds like a great idea. We can have a team. A feature team is a team that works picks up a requirement and works on it all the way through the stack, and then move between different parts of the architecture, never owning anything, but just sort of picking up a requirement and implementing it as they go. The upshot of this was that the software they were building had very, very fine-grained communications throughout the stack. There was nowhere where they had defined boundaries between different parts of their system. Everything was very fine-grained RPC-style communication. And you can actually trace that directly back to the team structure and how the teams were organized. And I think Melvin Conway's up there laughing at them and at the rest of us who think that's been something I used to advise, 5, 6, 7, 8 years ago. And he's up there going, ha, ha, ha. All right, you idiots. I told you about this in 1968. This was actually, Conway's law wasn't, there's a bit of a history thing here, but Conway's law wasn't originally accepted as a thing. But then a few years later, some decades later actually, MIT and Harvard, the Harvard Business Review got together and did some further research. They looked at many, many organizations, looked at many, many different types of software, looked at open source projects, looked at closed source projects, and they kind of validated his initial results, his initial stab at Conway's law. So this is what HB, Harvard Business Review and MIT came up with, right? So wall of text, I'll make that easier. So what they found was, this is in the results, tightly coupled organizations, even if not an explicit managerial choice, design naturally becomes tightly coupled. It's the first thing. And the second thing was that loosely coupled organizations, so where you've got coarser-grained communication between teams, the architecture that evolves is more modular. This is the kind of thing we want, right? Which of these would we prefer? Tightly coupled, modular, loosely coupled. This language kind of talks to the patterns that we strive for when we're building software. Just to ram this point home one more time. Tightly coupled organizations, your design naturally becomes tightly coupled. And this is a function of information theory. It's a function of how people communicate. The way people communicate leads to the software communicating in similar ways, more finely grained. But if you've got these coarse-grained boundaries, you end up with more modular architectures. That sounds interesting, because as I say, that's some sort of properties of software that we might actually want. So this is me. I won't talk too much about me. I did a thing with Martin. It was fantastic. I went for a sleepover, which was quite nice. Took my onesie over to Martin's home office. And we wrote this paper. The reason I bring this up is because we were trying to we were trying to describe, rather, the things we were seeing that were making organizations successful. Many of the other speakers at this conference actually were inspirations for us writing this, because they were doing things that were clearly being successful. So I'm thinking of Mr. George, who's sitting in the front down here, the work he was doing. I'm thinking of Adrian Cockcroft, the work he was doing. And we tried to assimilate all of that and put together a set of characteristics that sort of described what people were doing in a very broad sense. And yes, the first one of these is componentization via services. Breaking things up into smaller parts, into separate processes. Modularization around service boundaries rather than within code. But the second one and the third one, organized around business capabilities and the products, not projects, I see those, and this is what this talk is about, as key to building software that we can leave as a legacy, for a positive legacy for people who come after us. I'm going to channel Chad Fowler here. He's got this lovely phrase where he said we should be able to leave software as a positive legacy. IT is the only industry, software engineering is the only industry where the word legacy is a negative, right? Everywhere else, legacy means a positive thing. Bach's legacy. We want to leave a positive legacy for our children. Who wants to work on a legacy software platform? That's 0. Who does work on a... okay, right. Many. I heard a really nice phrase, again, 2 weeks ago in Spain, where the team were describing some of their systems as, not as legacy, but as heritage. It's a delightful phrase. It's the heritage part of the business and the current part of the business. So that's what I'll talk about. I'm going to talk about business capabilities and products, not projects. I'll use some examples from the work I've been doing, from the people I've been seeing, the clients I've been working with, and wider industry experience. So first, I'd like to start with a question. Why do we write software? And it's not a rhetorical question. To automate things, potentially. Any other ideas? It's fun. To solve problems. There was some more. To achieve business goals. I'm glad I waited, because this is the answer I was looking for. To achieve business goals, to create impact. And that might be in a number of different dimensions. I'll mention that in a sec. This is a great story. Oh, let's cut that slide off. This is a great story I picked up on the interwebinets, and it's a review of some software that Nuth wrote by Doug McElroy. It's described it's a book about literate programming, and McElroy says Nuth has shown us here how to program intelligibly but not wisely. I buy the discipline. I do not buy the result. And bear in mind, this is the guy who wrote all the books, right? Just bear that in mind. He has fashioned a sort of industrial strength Fabergé egg. intricate, wonderfully worked, refined beyond all ordinary desires, a museum piece from the start. Right. Now this describes half of my career. Building intricately constructed, beautiful pieces of software because it's fun, because I can use the patterns. It's enterprise amazeballs, right? I can throw all this stuff. I can make these intricate, beautiful pieces of software that solve a problem, but they're beautiful. The upshot. McElroy goes on in the comments to implement the same program that was implemented here and described as a Fabergé egg in a 6-line Unix script. And his point was, yes, we can spend all of our time having fun, solving problems in these intricate, beautiful, wonderful ways. But we can also be pragmatic about these things. We can build software built up of small components and be pragmatic about this, about our approach. Because the purpose of building software is not about having fun, really, although that's a bonus if we get to have that at the same time. The purpose of building software is to create business impact, as we heard over here, right? So it's either money, right? We either want to increase the total economic value of the company that we're working in, we want to increase profits in some way, or we want to do achieve some other goal. So this is a tweet from one of our team, or several of our teams got together to create an iPad app that could be used inside the red zone in Ebola-struck countries. That's not making money, but it's certainly having business impact. This is the reason we create software. We create software. And therefore, to answer the question, how do we beat our competitors? How do we go as fast as possible? How do we create the maximum business impact? We should look beyond the boundaries of just the lines of code we're writing. We should look at how our teams are structured, how our teams communicate, how our organizations are put together. We can achieve positive business impact. So, why do we like the style of building microservices? So I'm calling out here, this is the promise, this is the goal, this is the idea, this is the dream. Right? Microservices give you software that's cheap to replace, quick to scale, withstands failure, and should allow us to go, to quote Adrian Cockcroft, as fast as possible. But I hear a lot about problems that teams face that impact their ability to go as fast as possible. Quite a lot of them end-to-end testing, things like independent deployment, right? Can we deploy things individually, or are we creating these sort of distributed monoliths? And things like service versioning and evolution. But those aren't the things I worry about. I worry about organizational design. So I'll talk about some examples. So this you might, certainly the people who self-selected as working in legacy platform, heritage platforms rather, might recognize some of this. So this is a standard organization, right? I've just laid it out in a nice circle. You've got role-based silos with separations between different business units. You've got testing, operations, architects, development, sales, HR, etc. Right? And I'm including the wider business functions here as well as people writing software or involved in writing software, operations. So I did a bit of work recently to visualize dependencies in software. Right? I think there's a phase in everyone's life where you have to start playing with software visualization. This is the phase in my life when I'm playing with software visualization. And I started building things in D3 that look a bit like this. It's all very nice. I think that's Spring and the dependencies within the Spring framework. If Josh is in the room, then that's the dependencies in your software, mate. Just saying. And I was thinking, is it possible to actually visualize this, visualize organizations and teams in the same way? And what insight would that give us if we could do that? So I sort of thought, yes, we can. This is something called a chord diagram. This is a pretty standard visualization technique, a chord diagram. And essentially the lines on here are the paths of communication within an organization. So you can imagine when requirements come into say, or maybe requirements are generated by sales, they hand them over to the project management office in a big batch. The project management office look at the requirements and say, we need a team to do that. They assemble a team, hand it over to development, or maybe to architecture. The architects hand it over to the software developers. They do some work. Obviously, they don't get a say in how to do it or what to do, because the software developers, we're the stupid ones, right? The smart people work out what we need to do and tell us how to do it. Isn't that how? That's how software works, I think. And then you do some stuff. If you're lucky, you don't have to hand it back to the architects, because what they came up with was complete nonsense. If you're lucky, you might just be able to implement some stuff. Then you hand it over to testing. They break it. They hand it back to development, and so on. And you can look at it a different way. This is from a real organization I was at a few years ago. So this is essentially a value stream map without the timings of their software development process. You can see all these lines are handoffs in their organization with different roles down the side. Incidentally, there's this tiny bit over here, I'll point at it, with the ones and zeros. That tiny bit with the ones and zeros, that's where we work, right? That's the only part of the process where we get involved. And when I was looking at this, I was thinking of this kind of game, right? It's essentially snakes and ladders, because you're taking one step forwards, 2 steps back. You've got these handovers. You've got these large batches as people are handing requirements around. You've got queues of work in lots of different places. And if you've come across the Principles of Product Development Flow by Don Reinhartson, he describes very eloquently in that queues essentially are the source of many of the problems that we have when we're building any form of product rather than just software. You've got all these queues, you've got these large batches. We're almost deliberately destroying value by organizing in this way. Deliberately destroying economic value. Because we think if we organize like this, it'll be more cost effective. It'll be more efficient. We'll put everyone who does the job in the same place, right? That's got to be efficient. All the testers will sit together and they'll all do testing. Awesome. All the PMOs will sit together. They'll all do whatever project management office people do. What you're not doing in this form of organization, any project management people in the room? There's the people laughing over there, I'm guessing. What you're not doing here is optimizing for value, optimizing for minimal queues, optimizing for minimal handoffs. And if you take a look at another book, Lean Enterprise, by a former colleagues of mine and a current colleague of mine, they describe in a lot of detail the economic impact both of organizing in this way, and also how you can shift big organizations to operate in a more value-based way. So, why is this bad? I sort of described this idea of deliberately destroying value. See, every one of these chords in this diagram, in software they would represent coupling between components. In this diagram they represent delays. Each chord represents a delay in how we do our work. It's a great quote from Peter Drucker. There's nothing so useless as doing efficiently that which should not be done at all. Many of the things we take for granted, that we have to go and get permission to do things, that we have to go to the important people, because the important people are up in the hierarchy, and so therefore they're important, and therefore important people take important decisions. So we have to introduce these delays talking to people. Every time we start doing this, every time we introduce these chords, these delays, these handoffs, every time we introduce batches, we're destroying value. So, I mentioned business capabilities at the start of this. Let's describe what one of those is and why we suggested that you might want to organize around those rather than something else. So this is a definition. I think this is from Microsoft, actually. What's happened to the slide? Sorry. It's a capability is a combination of people, processes, and systems that provide value to customers, internal or external. The key thing to take away from what a business capability is that it's the what of the business, not the how of the business. Right? Often we think about splitting up our organization into around business processes, right? Or maybe nouns, entities in our system. entities in our domain. But actually what we say when we say business capability is we should organize our teams around things that don't change, things that are long-lived within our organization. This is maybe not true in lean startup land because you might want to pivot, but an example of that might be if you're in a supermarket, if it's a supermarket chain, a better example might be insurance, right? You're always going to have to provide quotes to people. You're always going to have to provide essentially risks to people. So there are business capabilities around things like calculating how much of a risk someone is. That's always going to happen in insurance. There's a business capability around providing information to customers, et cetera, et cetera. Those things aren't going to change in the insurance domain. So here's another example. This is a map. We might have a retail organization that has capabilities which is essentially selling stuff and delivering stuff. This is from a real example, company I worked at. They were split between 2 different continents. Selling stuff happened in one place, and delivering stuff happened in another place. And they had large teams organized around these capabilities. And if you don't know how messaging works, this is my brief introduction to messaging. They sent messages between them. This is very coarse-grained communication across a very coarse boundary, right? So this is 2 different teams, 2 different continents, exchanging messages. This actually worked really, really well for them. Because not only were they able to work in isolation from one another, but also there was this very stable boundary where they just did message passing. So they were very decoupled and very cohesive. Awesome. Unfortunately, in this case, they were also working in sort of project teams rather than product teams within these capabilities. So they had very fine-grained communication, as I mentioned earlier, within these different teams. And they had tons of people. There's like hundreds of people on either side of this, delivering stuff and selling stuff, building the websites for retail, building the fulfillment systems on the other side to send people things. And they had hundreds of people all hammering around, chasing all around the code base. They'd start a project, deliver some requirements. They'd wander around the code base. And in the end, they ended up looking like, this is the project thinking. In the end, they ended up looking like, wait for it, it's worth it, that. Conway's law. They ended up having these really fine-grained RPC-style communications between individual services inside these capabilities. So they got the kind of macro scale right. They got this idea that we should split up into these separate business capabilities right, but they hadn't followed through on that. They hadn't recognized that the thing that was making that work was this coarse-grained communication. And they ended up with this very fine-grained communication internally. And that meant that for each of these, and there was probably 30 or 40 individual services in each of these capabilities, delivering them, each of these capabilities had to be deployed all at once. Right? They built, I think Sam coined the phrase maybe, Sam Newman, they built a distributed monolith. And again, Conway's law is laughing. Melvin Conway is laughing at them from the balcony here. You learned one lesson, what about the others? There were some other effects of this, so one of which was this idea of having a 6-week period of hardening that they had to go through. So they'd work, in an agile way in sprints, 2-week sprints, awesome, and they'd finish their 2-week sprint, and then they start the next one. And after 3 of these, they'd sort of hand this off to a hardening team who had to test everything all at once, had to do regression testing against everything all at once, had to spend this time hardening. They also had this problem where each of these services in the individual fine-grained ones, they had this problem where they were fanning in to these sort of end-to-end tests. So their deployment pipelines looked a bit like this. Build, unit test, service test, and then fan into all these product tests at the top. And this was really limiting their ability to get stuff done. And again, this idea of deploying everything all at once. So they sort of got this idea that batch size is a problem, right? Because they were working in an agile fashion, 2-week sprints. Limit the amount of work you've got in progress at any point. Right? Get stuff out as effectively as you can. But then hit this wall after 3 sprints where they had to basically batch all those 6 weeks worth of work up, test it all at once, deploy it all at once, introduce a massive amount of risk into the process. And this was really painful for them. Beware the distributed monolith. This is not as fast as possible. This is a recipe for a nervous breakdown. So, if that's the case, what might good look like? I'm going to go to an odd place to illustrate this. So, anyone know what that is? That's the Ebola virus. Yeah, absolutely. So, I read this article in a newspaper in the UK last year, I think it was. It was about this lady, Pauline Kafiki, and she was a Save the Children sponsored nurse who went out to Africa when the Ebola crisis was at its peak. And she was one of the 3 Brits to contract Ebola when she was out there. She was flown home, and she was transferred to the Royal Free Hospital in central London, which is this, the kind of centre of excellence for infectious disease treatment in the UK. That's harder to say first thing in the morning than I thought. So she was brought there, and she was very, very poorly, as you'd expect. It's a vicious, horrible disease. And she was treated by this team, a whole bunch of them. This is the consultant down the bottom who was in charge of her treatment, and he was the guy interviewed in the newspaper article. There's a number of about 30-odd people involved directly in her treatment. And she survived. She spent some time in hospital, obviously, a few weeks, and she got better eventually. And this made me think: this is an environment where going faster than our competitors in this case, being able to make decisions about treatment really, really quickly is massively important. So I was thinking, what are they doing? Well, how are they organized in order to give themselves the best chance of treating this disease? Because, I mean, you look at an IT organization, you look at a business, it's got capabilities. Similarly with a hospital, you've got different capabilities in a hospital. You've got things like facilities, finance, microbiology, etc. And similarly, you can plot this as a sort of chord diagram. And if you look at this, as I said, all these lines represent delays. Now, surely, as I was saying, surely they want to minimize this when they're trying to treat someone who's desperately sick. This is the OODA loop from John Boyd, Colonel John Boyd. He was a fighter pilot who went on to effectively define the US military's doctrine for warfighting, certainly in the Air Force, but also a lot of the lessons were taken by the Marines and other parts of the US military. And what he said was, in order to win a dogfight, you need to make decisions and execute on them faster than the person who you're in a dogfight with. And if you do that, you will win, all other things being equal. So you should optimize, he said, for going around this thing called the OODA loop. Observe, orient, decide, act faster than your opponent. And actually, as I say, this idea has become enshrined in American military doctrine and has spread out around the world. An example of that is the switch from big, heavy, 2-engine fighter planes to single-engined fighter planes. That's the direct result of this idea that you should be able to go around this loop. You should be able to outmaneuver your enemy. So thinking, this is the sort of thing that they want to do in a hospital. They want to be able to go around this OODA loop as quickly as they possibly can. If you introduce delays into this OODA loop, if you introduce, I have to go and talk to the microbiology people, they're in a different building, that's going to blow your chances significantly of achieving business impact, achieving a positive outcome. The article went on to list the people involved in Ebola treatment, in Pauline Kafiki's case. There was, as I say, about 32, 33 people. In bold, there's about a third, you can't really see that, there's about a third of these are clinicians. Right? A third of these people are clinicians. The rest of which, though, 2/3, are support staff. Housekeepers, cleaning people, porters. Right? And to quote Dr. Michael Jacobs, the consultant involved, if you imagine all the functions a hospital has to have, not only the doctors and nurses, but physiotherapists and pharmacists, but estate management, food facilities, laundry, all of them have to be involved. And they all have to be specially trained and safe to work in this environment. So what do they do? How do they do this? Well, they don't have this organization in the hospital when they're treating infectious diseases. They don't have all these handoffs and delays. Rather than that, they bring everyone together into one place. They minimize these handoffs. They minimize the amount of waste that they have so that they can go around this OODA loop as fast as possible. So I thought that was interesting, because these are like cross-functional teams working with a single purpose, focused entirely on, in this case, patient outcome. Now that sounds like something we've been striving towards in software for quite a while. Turns out there's a bunch of people around who are already doing this. All right. This is not just hospitals. This is other environments as well. This is from a study from a long-running ThoughtWorks engagement in Australia, actually, where there was some analysis done on requirements and how long they took to cycle through our teams. All right. And there was an order of magnitude difference in how long they took to cycle if they stayed within a team or had to go across teams, introducing these delays. And as I say, this is true for the trauma teams, treating accident victims in trauma units. My sister's a trauma nurse, and this is how they do it. Formula One teams, this is exactly how they organize. You don't have test engineers separately from when testing is done of a new car, everyone is involved. It's not just the drivers going off and then 5 weeks later giving some feedback to the engineering team. Everyone is there. Everyone is executing on the same plan. And in the the military example would be the US Marines. People think the US Marines are organized in this really hierarchical manner, right? Where any decision would have to go up to some important person, right? A squad leader, a captain or a major or something, to get a decision about what to do, whether to change what they want to achieve. And actually, that's not the case. In the Marine Corps, decisions are pushed right down to the very bottom of the hierarchy. But they compensate for that by having things like a tactical doctrine. They spend 6 to 12 months or whatever it is training together. So they can answer the question, what would my friend do? And they also have this idea of, I think it's called commander's intent. So you should, every member of the Marine Corps should know the intent when they're on operations, the intent of their commander 2 levels above. All right. And not just what they're going to do, but why they're going to do something. So the example I heard from Don Runnison was this idea of, if you want to if you've been tasked with taking a hill, you don't just tell a team to take the hill. You say, we want to take the hill because if you take the hill, we can achieve some other goals. So we can be spotters for people crossing a river. And that means the team can flex, can change direction. Right, the unit that's going to take the hill, if they find it's too difficult to take that hill, can take another one instead, because they can still achieve a positive outcome. This is another example of minimizing delays, pushing decision-making down to the lowest level you possibly can, and getting cross-functional groups together in order to make those decisions effectively and quickly. So what about software? Because that's all very good, but turns out none of us are medics. I don't know, maybe some are, but I'm not a medic. How does this relate to software? So, there's an example, this idea of cross-functional teams organized around lines of business. All right. We've moved to this model in the last few years. If you think about the idea of having, the sort of XP-style cross-functional teams with your testers, your product management people, all involved, product owners, your business analysts, all in one place delivering software. That's kind of modeled on this idea, and it's proven very effective. I'll give you a quick example. This is an insurance company I worked at some years ago. I have to be quite careful because there's some people from that insurance company in the room. So hopefully I'll get this right. Otherwise, they'll ask pointed questions. When I first started working with them, they had a heritage platform, shall we say, which was organized. It was a big monolithic thing with all the different products that they were selling all lumped in one place, big monolithic database. There were historical reasons for that. And over a period of years, and this is still an ongoing process, they're over there. This is still an ongoing process. Over a period of years, they reorganized both their teams and also the software along the lines of their products. So they separated out the different product lines from the big monolith, from the big heritage application, into these separate lines of business. So in this case, it's like home insurance, motor insurance, life insurance. Separate lines of business with cross-cutting concerns, because you don't want to duplicate everything across these verticals. So cross-functional teams delivering lines of business. And this is Conway's law in action. Because between these teams, there's a very coarse-grained interface. Within the teams, fine-grained. Right, so they've got good fine-grained communication within the teams. But the fact that there's coarse-grained interface between teams and between the cross-cutting concerns means that Conway's law is acting to reinforce these boundaries. So, cross-functional teams organized around lines of business. Melvin Conway's going, yay, we think. If we model this again as a chord diagram, what does that look like? Well, we've still got all these lines, right? We've still got all these chords. We've still got lots of delays in our system. Melvin Conway's laughing at us again. But fortunately, we can play the Jez Humble card. We can go further than this, right? We can go further than simply the cross-functional teams with lines of business. DevOps, woo, bingo. Mark it down. And not really DevOps, but continuous delivery, right? And I use this in the sense that we have developers and operations people, often and if possible, the same people working in the same teams. All right? So we can subsume operations into our teams. So now we've got cross-functional teams, we've got operations, we've got everything we need to have within a single team. We can make decisions really, really quickly. We can execute the OODA loop as fast as we can in this example. But of course, Melvin Conway is still laughing at us. All right? Fundamentally, he's still laughing at us. Each of these capabilities can be tested and deployed independently. You've got the cross-cutting capabilities which can be tested and deployed independently too. But can we go further than this, right? So we can start organizing around lines of business. That's great. So the idea is it's like turtles all the way down. Or it's like Russian dolls. Once we have one distinction, one coarse-grained boundary, we can, within those boundaries, create others. Because obviously if you've got a team of 10 people, that's great. But if you've got a department of 500, you can't just have 5 teams of 100 people each. So there's some organizations that we've been working with globally. There's one that's on record in Australia, is talking about this, Real Estate Australia, about how they moved away from just this sort of cross-functional team idea and continuous delivery idea, and actually brought all their business people in as well. And I don't mean just their product owners who are proxies for the business. I mean actually their business people. So, on a floor of their organization, say it's what would be a good example of this? Residential property, so they're real estate. So they'll have a floor, which is the residential property floor. On that floor, it's the line of business, on that floor they'll have the MD, they'll have salespeople, they'll have everyone involved in generating profit from that line of business, sitting in with all the development teams, sitting in with which are composed of people who are doing operations, who are following the kind of build it, run it model. So rather than have these discrete silos, role-based silos in the business as well, they're subsuming that, they're bringing that into this idea of having cross-functional product teams. They have these lines of business which are decomposed into value streams, and these are decomposed further into teams. And crucially, each team owns one or more services. It's this Russian doll thing. So you have one organizing structure with coarse-grained communication across to another, and as you get chunked down in terms of the size of the number of people involved, you follow the same principle. In REA, they talk about 10 to 20 people as a value stream. Sorry, as value stream. 160 to 200 as a line of business maximum. And if anyone recognizes the 160 to 200 number, that's quite a famous number. I think it's Dunbar's number. So this is the number of social connections you can keep in your head at any one particular point. Rye smiles from the front row. It was originally 160. New research has pushed it up towards the 180, 200 mark. So you're organizing around groups of people who can keep social connections in their head. You're organizing around lines of business, value streams. And you do that in multiples thereof. This might sound very, very similar to the guilds tribes and squads model that people have probably heard about. And it is very similar to that. It is very similar to that. I'm not using the hipster word, I don't know. But crucially, this is based on real research. This is not something we make up, right? This is about going as fast as possible. This is about beating our competitors, generating the most value, generating the most business impact. And it's based on real research. This is from '77, Managing the Flow of Technology. It's still absolutely relevant today. And in this book, which is it's a study of how communications operates in R&D departments. So engineering R&D departments. And this is a graph of the probability of weekly interactions between groups of people, depending on how far away from each other they sit. It's quite interesting, this graph, because what it says is, if you get over about 10 meters away from someone, the probability of you having a serendipitous chance conversation about work on a weekly basis with that person drops to 0, more or less, right? 0.05% probability that you'll have this random conversation with someone. And serendipitous conversations about things that both parties are interested in are really important when you're working as we do doing knowledge work. And the advice back then, and this was implemented in quite a few organizations, was to co-locate as much as possible, because you can take advantage of these communications. Again, reinforcing the Russian doll idea of having, fine-grained communication at the team level, and then as you expand out to different scales, organizing around Dunbar's number and co-location. Obviously, things have changed since 1977. Slack, for example, has, you might want to point that out to me, but yes, of course, things have changed. And also, the environment has changed, working conditions have changed, more people want to be able to work remotely and so on. But these results are still very, very useful, because what they do is demonstrate the importance of having things like always-on, like video, of doing remote pairing, of making sure that you're able, that you, as far as possible, if you're in a team which requires fine-grained communication, you have that fine-grained communication. And also, and I'm going to finish on this more or less, also these structures, the interesting thing about these structures, and this is where Conway's law, I think, really helps us, is that they're isomorphic with things like API boundaries. These team structures, you can model your APIs around these things. This is the stability onion. So, for example, for a line of business, right, communication, very coarse-grained communication externally to a line of business, you might want to apply certain patterns. You might want to apply different patterns if you're talking about very, very fine-grained within team communication. And there was a statistic I heard from Netflix, I think, which was there was the ratio of changes that impacted external to a team to internal to a team was about 1 to 10. So for every 10 changes you made inside your team boundary, which is very fine-grained, you could have a conversation with the person next to you about that change. There was one change that required going across going across to another team, which implies you do different things at those boundaries. You don't always have to apply all the same patterns. I mean, there's some patterns here: semantic versioning, contract testing, tolerant readers, conversational change. Contract testing is really, really useful at a certain level within our organization. And as I say, I'm using team now and almost service boundaries synonymously. But you might not want to do contract testing externally to your organization. I can't imagine Google Maps API. I can't imagine if every single person who used the Google Maps API, every single person submitted a contract test to Google and said, "Can you run this on your build system for me?" I'm not entirely sure that would be very successful. But contract testing between teams, that's a really useful idea. If I'm a team and I need to work with a service provided by a different team, and I can write a contract that can be executed by that team, that's really useful. So you might want to do different things at different levels within your organization, at different levels of organizational structure, and you can organize your microservices architecture around these boundaries as well. So, thoughts to finish. This is otherwise known as the inverse Conway maneuver, right? So my colleague Evan Botcher, he's the Southern Hemisphere, James Lewis, he says, design the organization you want, the architecture will follow, kicking and screaming, if necessary. The other thing is, I think, and there's probably some interesting work to do here, because I suspect there are signals that Conway, Melvin Conway, we can, if we sort of cup our ears and sort of listen, we can probably hear Conway laughing on his balcony, and this in response to certain signals. So what are those signals? Well, maybe things like constantly ordering work across boundaries. If we constantly have to hand over stuff across team boundaries, then that's probably a signal that we haven't got stuff quite right. There is still delay, there is still waste in our system. If we have to split stories between teams, things like having to constantly move people around because you've got experts who need to move around, rather than because you actually want to do that as part of your, you want to do that in order to spread knowledge. What about things like deploying in lockstep on this idea of fanning in for end-to-end testing? I suspect all of these things are signals from Melvin Conway sitting on the balcony laughing at us. So maybe watch out for those. So I'll finish on this thought. Structuring our teams enables microservices, I think, to evolve independently. That's what I've seen. And this is down to this idea of the inverse Conway maneuver and the idea of business and architecture isomorphism. And if we can do this, and we won't get it right all the time, but if we can do this and then evolve, it should help with everything else. Thanks very much. I'm now waiting for Adrian to ask the first really difficult question, because that's normally his trick. But he's not sitting in the front row this time, so I'm a bit disappointed. Any questions? Awesome. Everything was exactly clear and obvious. So thank you all very much. I'm around for the rest of the... Oh, there is one. Yes. Sorry. So a tightly coupled organization is characterized as one where there is lots of fine-grained communication between roles that live apart. So an example might be... what would be a good example of that? Well, actually, a good example. So if you're running projects, if you have a project team, generally there are two options, right? When you're structuring stuff, one might be to focus around the idea that we want to optimize for efficiency, right? So we'll have an operations team sitting over here, and they do business as usual change, and they manage systems and that kind of thing. Right? They're sitting over here. They've got a ticketing system, right? And then we've got developers over here, right? And those developers come together into small projects which fertile around in the code bases, and then finish the project, and then throw that software over to operations. And then the next project comes up, developers get assigned into a new team, they fertile around in the code base, and they take that software and throw it over to operations. And the next project, the next project, the next project. What I've tended to see in those sorts of situations is that developers optimize for the local minima for the project. Right? We want to get the thing we're working on now done as effectively as possible. So we'll optimize for things like the simplest thing I can do. Maybe it's RPC calls, for example. And in that sort of when that proceeds over a long period of time, what you end up with is lots of projects, each implementing the local minima, the local maxima. I'm getting the words wrong. Each implementing the local maxima, and because each of these project teams has got fine-grained communication going on, the architecture tends to get sucked together, either into a monolith, or you end up with things like very Corba-like RPC-style communication between services over time. I tend to waffle. I'll put my hands down. Any more? Yes.
If you're called to a consulting gig, I think it's one thing to notice that the organizational is actually the problem, and to have the impact to actually change something. How do you approach this difficulty?
So that's a great question. So I'm a consultant. Everyone's going to laugh at this. Everyone laughs at the consultants. So the question is, it's one thing to actually observe this, and it's another thing to actually do this. So I'll give you an example, actually, where I personally did this, which is inside ThoughtWorks. So we had this in our technical organization. We could call it tech ops. We had this kind of model where we had lots of projects running, and then people would sort of, when you finish on a project, move on to something else. And we ended up, and I've got a slide somewhere which I daren't show, we ended up with this horrendous kind of systems landscape of kind of databases talking to databases. We even had something called the middleware database, which was nice. And they'd got the message that you don't use an enterprise service bus, but we're using a database to do the same thing. And what we did in that case was we took a look around. We spent like a few weeks looking at how the organization worked. We took some time to understand what business processes internally we had. And then we put a plan together and said, actually, we need to change this. We need to have teams organized differently. We need to have teams building out simple RESTful microservices that do one thing. And they need to be long-lived. They need to own these services for the lifetime of them. And it's, I think Sam is the tech ops architect, technically, in Sam Newman over there.
It's taken about 3 years.
Yeah.
It's better than it was.
Yes. Better than it was. Another example, I mentioned I worked with this insurance company. They're actually sitting over there. Go and talk to them about it. Because I think it was 5 years ago I started working there where we did a similar thing. We took a look around, noticed some discrepancies in how they could be more effective, rather. And it's still ongoing. 5 years, yeah. I mean, organizational change takes 4 to 7 years. That would be mine. And it's not easy, and it costs a lot of money. Okay. Oh, no, more. Yes. You're in your break time. I should point this out. So,
about the turtles inside of the turtles,
yeah,
all the way down. I was thinking about this, how you approach this when you have geographical boundaries, say. For instance, a brand that has a lot of shops around the world. Could you sort of draw that in that diagram? Such an organization?
Maybe I can draw it like a castle in the air rather than on my laptop. No, I mean, okay, so the question is, what about when you've got organizations that have, I guess, physical presences in different locations, for example, bricks and mortar retailers? Bearing in mind that microservices is simply one architectural style, and it might be the architectural style that your organization would like to adopt for various reasons, but that should be based on the organizational strategy, corporate strategy. I'm going to say the dirty word, dare I say it, enterprise architecture of the organization, right? So that should be driven by corporate strategy. And the enterprise architecture that you desire, right, might be different if you've got this sort of setup. I'll give you an example. So you might choose to do different things if your strategy suggests you want to standardize all your business processes in one place. Right? Or you might want to have variances between different locations, between different geographies. You might want to allow different geographies to vary their business processes. That would imply doing different things. I guess in that sort of example, if you've got different geographies with varying business processes, then you might want to have a value stream in one place and a line of business in one place and a line of business in another place, which implies duplication of function across those two locations. And if you look at that through the lens of cost control, seems insane. But if you look at it through the lens of what the corporate strategy is and how effectively you're going to be able to deliver value, it actually makes a lot of sense. If you're focused on profit rather than cost, it makes sense, but only if it's tied to the corporate strategy. If your corporate strategy is to have complete standardization of business processes in one place, then you should go the other way. I guess what I'm saying is there's a great book, I think it's by some German authors, called Enterprise Architecture as Strategy. I suggest you go and have a look at it. Yeah, done. Done? I'm around. This is a break. Hooray. Thanks.
Okay, thanks.